Have you ever just stopped and wondered how a massive, multi-ton military jet can just slice through some of the most advanced defense systems on the entire planet and act like it was never even there? Well, today we're going to pull back the curtain on the absolutely incredible science and engineering of stealth technology. Okay, so let's dive right in by getting a handle on the scale of the challenge here. Modern radar? It's just astonishingly powerful. I mean, it blankets the sky with electromagnetic waves, and it's so sensitive it can track something as tiny as a bird from like 100 kilometers away. It's wild. And that right there is the billion-dollar question. If a bird shows up on the screen, how on earth does a massive piece of flying machinery, just packed with fuel and weapons, just vanish? Well, the answer isn't magic. It's this incredible symphony of brilliant, mind-bending engineering. So to figure out how to beat radar, engineers first had to completely master what makes it work in the first place. And really, it all comes down to one thing: how much of that radar energy an object reflects back to where it came from. And this brings us to the single most important term in the entire world of stealth: radar cross-section, or you'll hear it called RCS. The easiest way to think of it is as an object's electronic size. A big, flat reflective object has a huge RCS. So the whole goal of stealth is to make the RCS of a giant fighter jet as tiny as possible. And what's just mind-blowing is the sheer scale of the difference here. Look at this. A conventional fighter jet has the radar signature of a pretty big truck. A stealth fighter, though, it shrinks that signature all the way down to the size of a marble. I mean, that's not just a small tweak, that's a complete, fundamental transformation in what a radar system can actually see. So how in the world do you do that? How do you turn a truck into a marble? Well, the first and most critical solution has absolutely nothing to do with being invisible. It's all about geometry, shaping the aircraft so it's a terrible mirror for radar waves. Okay, imagine shining a flashlight at a flat mirror in a dark room. The beam comes right back at you, right? Bam, that's a normal airplane. Now, imagine shining that same flashlight at a shattered disco ball. The light just scatters in 1,000 different directions. That's a stealth aircraft. The radar signal hits it, but it gets bounced away everywhere except back to the detector. And you can literally see this idea evolve over time. Early designs like the iconic F-117 Nighthawk look like something from a sci-fi movie. That's because the computers they had back in the 70s could only really calculate reflections off flat panels. But as computing power just exploded, engineers could design the smooth, blended, almost organic curves you see on aircraft like the B-2 bomber, which are both incredibly stealthy and way more aerodynamically efficient. But here's the thing. Shaping the aircraft is only half the battle. Because even with the most perfect geometry, some of that radar energy is bound to reflect back. So, engineers added another layer to the solution. They started asking a new question. And this is the second layer of the stealth onion, you could say. Instead of just redirecting the radar beam, what if you could make the plane's skin act like a sponge, soaking up that energy so it just never escapes at all? This is the job of something called radar-absorbing materials, or RAM. The best way to think about this special skin is like the foam padding in a soundproof room. Materials like tiny iron particles mixed into ferrite paint literally vibrate when they get hit by radar waves. And that friction converts the radar energy into a tiny, harmless amount of heat, effectively trapping the signals so it can't bounce back. But, being stealthy isn't just about fooling radar. Military aircraft have another massive giveaway. They are unbelievably hot. And this creates a totally different kind of signature that needs its own whole set of clever solutions. Think about this. A modern jet engine's exhaust can reach temperatures over 1,500 degrees Celsius. To an infrared sensor, that's basically a giant bonfire in the sky, which makes it a super easy target for any heat-seeking missile. So how do you hide a bonfire? Well, first, you literally hide the hottest parts of the engine from view. Then you flatten the exhaust nozzles to spread the heat out, kind of like spreading embers so they cool faster. And finally, you actively mix that scorching hot exhaust with cool air from around the engine before it ever leaves the plane. Each step just dilutes that heat signature, making it so much harder to lock onto. Okay, so we've covered deflecting radar and absorbing it, and we've hidden the heat. But actually combining all of these principles into a real-world, functional combat aircraft, well, that creates a whole new set of engineering headaches and some really tough compromises. Take this, for example. You can't have a perfectly smooth, stealthy shape and then just hang a bunch of missiles and bombs under the wings. Every single one of those is a giant radar reflector that would just scream, "Hey, I'm right here," to any radar system. So the only solution is to carry absolutely everything inside, in internal weapons bays. And we can really see these principles being applied and perfected across generations of aircraft. From the pioneer, the F-117, to the globe-spanning B-2 bomber, to the absolute air dominance of the F-22, and the multi-role workhorse, the F-35. Each one is just a masterclass in balancing all of these complex design demands. But this kind of capability, it doesn't come cheap, and it sure doesn't come easy. Stealth aircraft are fantastically expensive to build. Their special radar-absorbing coatings are delicate, they're fragile, and they require constant, incredibly difficult maintenance. And there is always a trade-off between being perfectly stealthy and being a high-performing maneuverable aircraft. So where does this constant cat-and-mouse game of detection and evasion go from here? Well, believe it or not, the next generation of stealth is already being imagined, and it is seriously wild. We are talking about ideas that sound like pure science fiction. Imagine shrouding an aircraft in a field of plasma to absorb radar waves, or using something called metamaterials to literally bend light and radar waves around the plane. Or, maybe even more likely, using incredibly advanced AI to actively jam and deceive enemy sensors in real time. Which really brings us to our final question. For every genius idea to hide, there's another genius idea to seek. As sensors, quantum computing, and networks all get smarter and smarter, the challenge of staying hidden only gets tougher. This incredible technological race between the seen and the unseen, it's far from over.